Hi, this is the Chapter 6 lecture on ionic compounds. Before we get started with the lecture, it is a good idea to get out your periodic table and some extra paper for any additional notes that you may need to take. And Chapter 6, we're going to talk about these things called ions, and then we're going to get into ionic compounds, how to write their chemical formulas, and how to name them. So if you remember in Chapter 5, we talked about the atoms and how the atoms are neutral, how they don't have a charge. And that's because the protons and electrons were equal. Now, the protons and electrons are not going to be equal. They're actually going to have a charge, and that's what we call ions, okay? So an ion is an atom that has a charge, and these charges can be either positive or negative, okay? And so here's an example, lithium with a +1. So on your notes, it's written correctly. It should be a little superscript like that, or sometimes the ions might have a negative charge. So it's usually written as a superscript in the upper right-hand corner to tell you what the charge is. Now, let's kind of go over why these ions might want to form, okay? And the main reason is they want to become more stable, okay? They want to become more stable. So, yes, these atoms will either gain or lose electrons to be more stable. So, which group of elements on your periodic table are considered stable? Does anyone know that answer? So, let's think about it. Okay, so yes, it would be group 8, your noble gases. Okay, your noble gases are the ones that are stable. And so these other atoms, they want to be like the noble gases. So in order to be like one of the noble gases, they have to either gain electrons or lose electrons in order to kind of be like them. Okay, they are not exactly a noble gas, but they will have the same number of electrons as a noble gas. And so that is what we're going to get to. And so since the noble gases are found in group 8, that's where this octet rule comes from. Okay? So they want to have 8 valence electrons. Valence means electrons in the outermost energy level, so electrons in the outermost energy level. And so that is the number that they will need in order to be stable. And we will talk about valence electrons more in second semester, but for right now, you just need to know that they want to have 8 valence electrons to be stable, so they will either gain or lose electrons to get there. So what we're going to do right now is we're going to go over the periodic table and the groups and figure out how many electrons they're going to gain or lose in order to be stable. Okay, so let's take a look at group 1 first. All right, so group 1, right there. Okay, so this whole group here. So let's take a look. Now let's just look at lithium. So let's kind of focus on lithium there. So you should have your own periodic table out also, so you can jot down what the charges are going to be above each group, okay? So for example, lithium. So what number is lithium on the periodic table? So lithium is number 3. So if lithium is number 3, that means it has 3 protons, okay? It has 3 protons. Now, lithium has 2 choices. Lithium can either gain, let's see, 1, 2, 3, 4, 5, 6, 7 electrons, okay? So lithium has a choice. It can gain 7 electrons and have the same number as neon, which is 10 right there. Or lithium can lose 1 electron to have the same number as helium, which is 2. So what do you think is easier for lithium to do? To gain 7 or to lose 1? So it would be easier for lithium just to lose one electron in order to have the same number as one of the noble gases. So therefore, lithium would have only 2 electrons. Okay? So don't forget that protons are positive, electrons are negative. So if we add these two up together, you end up with a +1 charge overall. Okay? So if you are not seeing that, let me write it out like this. 3 positives, 2 negatives, right? So then these cancel out and you're left over with 1 positive charge. So lithium will have a +1 charge. And what do we know about groups? What is the other name for groups? We also call them families. So remember, everything in the same family, they behave in a similar fashion. Okay? So then, yes, everything in group 1 will have a +1 charge. So put a +1 over the group 1. And that +1 means that it lost 1 electron. Okay, so I know it sounds the opposite. It has a +1 charge, but it's losing an electron. And so the reason why it's the opposite is because electrons have a negative charge. So that's why when you say lose, it's actually becoming more positive. All right, so now let's take a look at group 2. So here's beryllium. Okay, so let's take a look at beryllium in group 2. So let's see, it can either gain 1, 2, 3, 4, 5, 6. It could gain 6 electrons. They have the same number as neon. Or beryllium can go back 2. 1, and then go over here, 2. Or it can lose 2 electrons and have the same number as helium. So what do you think is easier for beryllium to do? Gain 6 or to lose 2? Yes, it's easier for it to just lose 2 electrons. So if beryllium is number 4, so if it has 4 protons and now it's going to lose 2 electrons, now it only has 2 electrons, and you add that up, and what do you get? +2. Okay, so everything in group 2 will be +2. Now let's take a look at group 3. Okay, group 3. So we're going to take a look at aluminum here. Boron, which is typically classified as a metalloid, typically you're not going to see boron in ionic compounds. Okay, typically it doesn't form a charge. But below boron, aluminum, gallium, and indium, and thallium and stuff, those ones there will form charges. Okay, so we're going to take a look at aluminum. So aluminum has a choice. It can either gain 1, 2, 3, 4, 5. It can gain 5 electrons, right, to have the same number as argon, or aluminum can go back 3. So if it goes back 3, so let's go back. 1, 2, 3. Or it can go back 3 and have the same number as neon. So what do you think is easier for aluminum to do? Gain 5 or to lose 3? Well, lose 3, okay? So it's easier for aluminum to lose 3, so therefore that will have a +3 charge, okay? And then typically right here in group 4, the only ones that really form ions are tin and lead. So I want you to highlight these or mark them somehow on your periodic table. And tin and lead are exceptions to the rule. And so they're just something that you have to remember, and you have to have these memorized, okay? So write that down somewhere. Tin and lead, Pb, okay, tin and lead will have what is called a multiple charge. It can have a +2 charge, or it can have a +4 charge, okay? So it can have a +2 charge or +4. So that's for both of them. So tin could be +2 or +4, and then lead can also be a +2 or a +4 charge. So once again, that is something that you just have to memorize. The other ones here, like carbon, silicon, and germanium, You're not really going to see those too often in ionic compounds. So since they're kind of right in the middle, they really don't form positive or negative charges. Okay? So the only ones from group 4 that you need to know are tin and lead. All right? So have those two charges memorized. So now what we're going to do is we're going to jump to fluorine over here. We're going to jump to the halogens. Look how close these halogens are to the noble gases. They're just one away, okay? So then let's write down fluorine. Okay, so here we have fluorine. Fluorine is number 9, so it has 9 protons. Okay, it has 9 protons. And do you think it's easier for fluorine to just gain 1 electron and look like neon, have the same number as neon, or do you think it's easier for fluorine to like go back 7? 1, 2, 3, 4, 5, 6, 7. So, what do you think is easier for fluorine to do? Gain 1 or to go back 7? Well, gain 1. It's easier for fluorine just to gain 1 electron. So instead of having 9 electrons, now it's going to have 10 electrons. Okay, so if you add this up, now that has an overall charge of -1. Okay, -1. So above the halogen group, group 7, put a -1 there. All right, -1. Now let's take a look at the oxygen group right here. So this one, or this group, can either 1, 2. Okay, it can gain 2 electrons to have the same number as a noble gas, or it can go back, 6? 1, 2, 3, 4, 5, 6. Or it can go back 6. So what do you think is easier for oxygen to do? Gain 2 or go back 6? Well, gain 2. It's a lot easier for it to just gain 2. So then, if it's gaining 2 electrons, it's gaining 2 negative charges. Therefore, that group will be -2. Okay? The last group that we're going to look at is right here, the nitrogen group. Okay? So nitrogen is number 7. In order for it to be stable, like one of the noble gases, all it would have to do is 1, 2, 3. It could gain 3 or it could go back 5. So what do you think is easier? Gain 3 or to lose 5? Well, gain 3, right? So therefore, gaining 3 electrons, gaining 3 negative charges, therefore it will have a -3 group. Sorry, -3 charge. Okay? So that group will have a -3 charge. Let's talk more about these ions. So the positive ions are called cations. Cations. It is not pronounced cations, it's cations. So these are the ones, once again, with the positive charge. So to help you remember that cations are positive, see how it has a letter T in here and it looks like a plus sign? So that's probably helpful for you to remember cations are positive. And they get the positive charge because they lose electrons. Okay, they lose electrons. And then the majority of your cations are metals. Metals. Hydrogen would be an exception to the rule. Hydrogen kind of always does its own thing, and you will also learn that hydrogen actually can form a positive charge. It can also form a -1 charge also. All right, so cations are positive. They lose electrons. They are your metals. And when we name a cation in a chemical formula, the name is unchanged. Okay, the name is unchanged. It doesn't change at all. It stays the same. Now let's talk about the ones that form negative charges. So the ions that form negative charges are called anions. Anions. So they form a negative charge, and they get the negative charge because they gain electrons. And these are your non-metals. And then we will change the ending to "ide." Okay, to "ide." So you probably have heard of like oxide, chloride, fluoride, and that's because they are anions, and that's why we change the ending to "ide." I also like to describe the cations as being like the girls, okay? So let's draw a picture of a girl. Cations, positive. Let's give her some hair. And you'll notice that I have awful drawings. So hopefully your drawings are a little better than mine. Okay, so here's a pretty girl, right? She's beautiful. All right, so cations, I like to say, are the girls. Anions, I like to say, are the boys. Let's give them some hair. Okay, now let's think of your electrons like weight. So girls like to lose electrons or like lose weight to feel more positive about themselves. Okay, so losing weight, losing electrons to feel more positive about themselves. Now boys are like anions, gaining weight or gaining electrons, they don't really care that much about gaining or losing weight too much, so they kind of get this like so-so face, like a line, which represents like the negative charge. All right, so girls are cations, boys are anions. Losing electrons, losing weight, feel more positive about themselves. Gain electrons, gain weight, just kind of like so-so. Okay, and there's another reason why I have the girls as cations, and that's because when we write chemical formulas, the cations are written first. Okay, cations are always written first. So think of ladies first. So that will also help you if you think about cations. Cations are like girls and anions are like boys. And also when we get into writing our chemical formulas, it is like you have to have one positive charge and you have to have one negative charge. So it's like opposites attract, okay? Opposites attract. So one's a metal, one's a non-metal. One is losing electrons, one is gaining electrons. And now we're going to get into writing ionic compounds. If you remember earlier, I was talking about the octet rule, how the atoms want to either gain electrons or lose electrons to have the same number as a noble gas in order to be stable. So some of you, these pictures might look familiar. In middle school, some of you learned about energy levels and the rings around the nucleus and all of that stuff. And this is what this is talking about. So here's lithium. Lithium has one electron in its outermost energy level, and nitrogen has 1, 2, 3, 4, 5 valence electrons. So lithium really wants to get rid of that electron right there. It wants to lose that electron so that it can be stable like one of the noble gases. And then nitrogen is like, hey, I only need to gain 3 more to have 8. And so that I can be stable. And so lithium and nitrogen are going to work together as a team. One is going to lose electrons, the other one is going to gain electrons in order to be stable. And so they actually transfer their electrons. And this is where we're going to get into ionic bonds. Ionic compounds, if you remember, they are formed from positive and negative ions coming together. So remember, the cations are the ones that are positive, and those are your metals. Anions are negative, and those are your non-metals. Okay, so one is gaining, one is losing electrons, one's a metal, and one's a non-metal. And this is how they make a bond. So now we're going to practice writing chemical formulas and naming ionic compounds. So get out your periodic table, and you will also need your common ion sheet, the one with the polyatomic ions and stuff on it, the one that you picked up the other day. So we're going to start off with an easy one. We're going to start off with sodium and chlorine. So we're going to put sodium and chlorine together to make an ionic compound. Now when we make our ionic compounds are neutral. They have no charge. Okay, so once again, ionic compounds are neutral. They have no charge. So on your periodic table, find sodium. It should be in group 1. And then what is the charge on the element in group 1? +1, right? Then find chlorine on your periodic table. What is the charge on chlorine? That's correct, -1. Okay, so sodium is +1, chlorine is -1. Now when we put these together, they have to equal 0. Okay, so this one is pretty easy. because we can do this math in our head, plus 1 minus 1, they already equal 0. So that means that we only need one of each. So then the compound is NaCl. And notice when I wrote this compound, there's no charge on it. That is indicating that it's neutral, okay, that it's 0. Now, you have to know how to name the compound also. So the rules for naming, the cation, the name does not change. So then it'd be sodium. And then don't forget, the anion, we're going to change the ending to "ide." So it's not going to be sodium chlorine, it's going to be sodium chloride. Okay, sodium chloride. Change the ending to "ide." All right, let's try another one. Let's do magnesium and nitrogen together. Okay, let's do magnesium and nitrogen. So let's find magnesium on the periodic table. And you should see that magnesium is in group 2, so then the charge on magnesium is plus 2. Now find nitrogen on your periodic table. And then you should find that nitrogen will have a -3 charge. Okay, so when we put magnesium and nitrogen together, we have a plus 2 and a -3. We have to make these equal 0, okay? The compound has to be neutral. So then what is a common multiple of 2 and 3? 6, right? 6 is a common multiple. So then let's take a look at the magnesium. If magnesium is plus 2, in order to make that equal 6, we need 3 of those, right? So we would use a subscript. Okay, now we're going to add subscripts to it. So 3 times 2 is positive 6. And then we know this nitrogen is -3, so that means we need 2 of those to equal -6. So then we have positive 6, -6. See how that equals 0? So then in the chemical formula, it becomes Mg3N2. Okay, so then this would be the correct formula for magnesium and nitrogen coming together. Then we have to name it. So the name would be magnesium and then nitride. Okay, magnesium nitride. Change the ending to "ide." Okay, change the ending to "ide." All right, let's do one more. Let's see, what should we do? Let's do K and O. Let's put K and O together. Okay, so find the charges on the periodic table. So I want you to write the correct chemical formula for it and then also name it. All right, so let's see. Potassium, you should find that to be what? +1. And then find oxygen on the periodic table. -2, right? So then how many Ks would we need to balance out that -2 charge? Right, we would need 2, right? We would need 2 of those. So then it would be K2O would be the correct chemical formula. The name would be potassium. Remember the first one, the name does not change. The second element, the ending changes to "ide," potassium chloride. Okay? Now also, I want to teach you this crisscross method. Do you have to do the crisscross method? No, you don't. It's just a little faster, but then sometimes I have to show you where you have to be careful with the crisscross method later in some examples. All right, so let's go back to the magnesium nitrogen example. So the crisscross method is you would just take the number from the charge, criss, take that number, cross. Okay, crisscross. So you see how the 2 from magnesium came to the bottom, right? This 2 came to the bottom here, and then the 3 crossed over there. Okay? And then when you do the crisscross though, you leave the charges off. You just want to cross the numbers. Okay? You just want to cross the numbers. So once again, the 2 comes down here, The 3 comes over there. And then if you even look at that for the potassium oxide example, it's a 1 would cross over here. But notice that we didn't write a number 1. Okay, notice we didn't put a 1 there. So if you only need one of the elements, you do not need to put a 1. It's already implied 1. And then the 2 crossed over there. Okay, so that's the crisscross method. It's a little faster, but once again, as we do some more examples, I'll show you where you need to be careful when using the crisscross method. Now let's talk about your ionic compounds that will contain transition metals. Okay, transition metals. The majority of your transition metals have what we call multiple charges. So for an example, copper can have 2 possible charges. Copper can be +1 or +2. Iron can be +2 or +3. So it's very similar to tin and lead. How tin, remember, could be a +2 or a +4. Same with lead, can be a +2 or a +4. So if it has multiple charges, when you name it, you are actually going to use a Roman numeral to indicate what the charge is, okay? But there are 3 exceptions, and these 3 exceptions do need to be memorized, okay? They are zinc. Zinc is always +2. Cadmium is always +2. And silver is always +1. So for these 3 exceptions, no Roman numeral required. No Roman numeral required for these 3. Once again, these need to be memorized. So look at your periodic table, and I'm going to pull one up right now. So you can see that zinc, silver, and cadmium are located right here. So you should highlight these or make them stand out somehow on your periodic table. So they make like a backwards L. Okay, they make like a backwards L on the periodic table. So zinc and cadmium are in the same group, so both of those are +2. And then silver over here is by itself, and that one is +1. All right, so now let's do some examples of writing formulas and naming compounds that contain a transition metal. So for this first example, let's use copper, and I'm going to tell you that this is going to be copper with a +2 charge. Okay, that's copper +2. And then let's combine this with fluorine. So find fluorine on your periodic table. Okay, what is the charge on fluorine? It's -1. Okay, so put these 2 together. So you can use crisscross, or you can just do the math in your head to figure out what the charges would have to be to equal 0. Okay? So go ahead and do this one by yourself. So you should pause the video and see if you can do it all on your own. And then if you do it correctly, it should be, you should get CuF2. Okay? So if you wanted to do the crisscross, the 2 would come down here, and then that one is just 1. So CuF2. Then to name this compound, it would be copper. We are going to use a Roman numeral, and we put the Roman numeral in parentheses after the name. Okay? We know the ending is going to be fluoride. Remember, change the ending to "ide." Okay, so now let's go back. Copper is a transition metal. It has a multiple charge, and the charge is 2. So then this would be copper 2. Copper 2 fluoride. Okay? So let's do another one. Let's do nickel. And this is going to be nickel with the +2 combined with phosphorus. Okay? So find phosphorus on your periodic table. And you will see that phosphorus is -3. So you can do the math in your head or you can do crisscross. So you should pause the video and see if you can do it all by yourself and then replay it. And if you do it correctly, it should be Ni3 and then P2. So if you did the crisscross, the 2 comes down there and the 3 over there. So you can very easily do crisscross, or you could do the math in your head. A common multiple between 2 and 3 is 6. And the name of this would be nickel. It is a transition metal that has a multiple charge, so in parentheses, we're going to use the Roman numeral 2 because nickel has a 2 charge. That is the one that we used. And then it would be phosphide. Okay, nickel 2 phosphide. All right, now, let's see. Now I'm going to give you the name of something, and then I want you to write the chemical formula for it. And this time I'm going to use tin. Tin, let me write out the name, not the symbol, so erase that. Okay, tin, let's do tin 4. Remember, tin, although it is not a transition metal, it does have a multiple charge, so you need to still use a Roman numeral for it. So remember, 10 could be +2 or +4, so this Roman numeral that I'm using is telling you that I want you to write the formula with 10 having a +4 charge, okay? So now I gave you the name, and now I want you to write the formula for it, okay? So 10 is Sn, and the Roman numeral is telling me that that has a +4 charge. That is going to be combined with oxygen, so you need to find oxygen on your periodic table, figure out what the charge is, and then you'll notice it has a charge of -2. Okay, so this is where I'm going to demonstrate the crisscross method and where you need to be careful. But a lot of you will probably look at this and you can do the math in your head, right? So then if you want these to equal 0, you would have 1 tin, and then you would have 2 O's, okay? Because if you had 2 O's, 2 times 2 here, that gives you -4, and that will cross out with the +4 there, making your compound neutral. Remember, the compound has to be neutral, it has to equal 0. So let me show you, if you did the crisscross method, what that would look like. So Sn with the +4, oxygen -2. Okay, so if you did the crisscross, 4 would come down there, 2 over there. So some of you might have put down Sn2O4. Okay, and this is where you need to be careful. These subscripts 2 and 4, you need to make sure that those subscripts are fully reduced. Okay, that the subscripts are fully reduced. So then to fully reduce it, you would divide both of these here by 2, and then that's how you get SnO2, like that. Here's a summary of all the rules on how to name your ionic compounds. So this is just all an overview. Some of the notes got cut off, but they're all written on your copies that you have. And now I want to do some examples involving polyatomic ions. So yes, make sure you have your common ion sheet out. Here is a list of your common polyatomic ions, and you have your list also, the ones that are on the common ion sheet. And I actually want to show you something on the names on some of them and how they're similar. Let's take a look at sulfate, SO4, the -2. Okay, this one is called sulfate. And sulfite is SO3 with the -2 charge. So notice that their chemical formulas are very similar, and then their endings on the name are also similar, okay, but they're different. One ends in -ate and one ends in -ite. So the one with the extra oxygen, we say it ate one more. See how this one is O4 and this one is O3? So the one with the extra oxygen 8, one more. So that's how you can remember which one should end in 8 and then which one should end in ite. So you have some other common polyatomic ions that are similar, like nitrate and nitrite, phosphate and phosphite. Now we're going to go over some examples that contain polyatomic ions. Okay, so let's write that across the top so you have this section. Polyatomic ions. Okay, so let's see. Let's do Na, which is sodium, and let's combine that with OH. Okay, OH is hydroxide. Okay, this is hydroxide. So you can find that on your common ion sheet. Okay, and then Na we know is sodium. So when you are naming an ionic compound that contains a polyatomic ion, the name does not change. Whatever the name is for that polyatomic ion, it just stays the same. Okay, so we know that cations, the name doesn't change, and then also polyatomic ions do not change. Now we have to write out the chemical formula for this compound. So you need to find sodium on the periodic table and find out what the charge is. Okay, so you should know sodium is in group 1, therefore that has a +1 charge. So same idea, they have to equal 0. Okay, the charges have to equal 0. The compound is going to be neutral. So then a +1 and a -1, they already cancel each other out. So it's just going to be NaOH. Okay, NaOH. All right, let's do another example. Let's see. Let's do calcium. So Ca, so this is calcium. Calcium. And let's combine calcium with PO4, and that has a -3 charge. So if you find this on your common ion sheet, it is phosphate. Once again, the names do not change if we are using a polyatomic ion, so it's just calcium phosphate is going to be the name of the compound. And let's see, find calcium on the periodic table. It is in group 2, so this has a +2 charge. So watch what I do on this one. Okay, if we do crisscross, this 2 is going to come over here, and then this 3 is going to come down over there on that side. All right, so then it becomes Ca3, and then the PO4, what you're going to do is you're actually going to group those together by using parentheses, and then you're going to put that 2 on the outside of the parentheses. Okay, we are treating this as one unit. All right, we are treating this right here, this whole polyatomic ion, as one unit. And we're saying that we want 2 of those. Okay, that we want 2 of those. So that's why we use parentheses around the whole thing, and then the number goes on the outside. But if we looked at this previous example that we did, notice that we did not use parentheses around the hydroxide. The reason why we did not use parentheses around the hydroxide was because we only needed one of those. Okay, we only needed one of those. So the rule is, if you only need one polyatomic ion, no parentheses are required. But if you need more than one of the polyatomic ion, then you have to use parentheses, and then the number goes on the outside. Let's do one more example involving a polyatomic ion. This time I'm going to give you the name of the compound, and I want you to write the formula. All right, so this one, let's do, let's pick a good one. Okay, let's do lithium. Lithium, and then let's do lithium sulfate. Okay, lithium sulfate. So you need to find these on your periodic table and also on the common ion sheet. Okay, so let's see. Lithium, the symbol is Li, And you should find the charge for lithium, which is +1. Sulfate is SO4, and that has a charge of -2. All right, so you can use crisscross, or you could do the math in your head, and then you should end up getting Li2SO4. All right, so notice that if you did crisscross, 2 goes there, and then you only need one of those, and then notice here, no parentheses. You did not need parentheses around the sulfate because you only needed one of them. Okay, you only needed one of them. Here are more examples on naming your ionic compounds. So you should try these on your own and then check your answers to see if you got them right. So yes, I want you to pause the video, do the problems, name them, and then check your answers. If you did it correctly, let's see. This one here would be calcium oxide. Okay, calcium oxide. Number 2, if you did this one correctly, would be potassium phosphide. Potassium phosphide. And then number 3 would be iron. And this one needs a Roman numeral, so parentheses. And then you had to figure out what that Roman numeral is. So then you have to work backwards, okay? You have to work backwards. Well, chlorine. You can find what chlorine is. Look on the periodic table. Find the charge for chlorine. And then you should find that that is -1. Okay, that is -1. And notice that there are 3 of them. So 3 times -1 gives you -3. So now you're trying to figure out what the iron has to be so that when you add them, it's going to equal 0. So since there's only one iron, then that means it has to be +3. Okay? So then therefore +3 and -3, it equals 0. So therefore, iron has a Roman numeral of 3. So it's iron 3 chloride. Okay, iron 3 chloride. So once again, we needed a Roman numeral for iron because it is a transition metal that has a multiple charge. It has more than one possibility for a charge. All right, let's go to PbO. So Pb is lead. Lead also needs a Roman numeral. Remember, lead can have a +2 charge or a +4 charge. So you have to work backwards. Oxygen. Look on your periodic table to find out what the charge is for oxygen. And then you should know that it's -2. Therefore, lead has to be +2, so that when you add those 2 up together, it equals 0. So this one's going to be lead 2 oxide. Okay, lead 2 oxide. Then the next one here, lithium. And then CO3 is polyatomic, so that's on your common ion sheet, and that is carbonate. Carbonate. Okay, so that's lithium carbonate. Then the very last one, number 6, barium. This is polyatomic, and that one is nitrite. Okay, nitrite, barium nitrite. So this is a summary on the rules on how you would write chemical formulas if you were just provided the name. So we already went over that. This is just a summary of everything. And don't forget that you could use the crisscross method to write your chemical formulas. You don't have to, but it is a technique that you could use, so it just depends what you prefer. In order to write your chemical formulas, you need to know your charges on the group. So this is review. So remember, group 1 is plus 1, group 2 is plus 2, group 3 is plus 3, and then you can see that on this periodic table it listed group 4 as having plus 4 or minus 4 charge. And that's not necessarily the case, so let's just cross that off. The only ones that you need to know from group 4 that form a charge, remember, are tin and lead. Tin and lead can be plus 2 or plus 4. Now if we go to the other side with the halogen group here, okay, -1, -2, -3. All right, so now we're going to review and practice using the charges and doing crisscross and writing chemical formulas. So here's a whole list of examples, and I want you to try these all by yourself. So pause the video and then play it to check your answers. All right, if you did it correctly, calcium phosphate. So calcium is plus 2, plus 2. Phosphate is a polyatomic ion. So let's kind of write these out a second. So calcium is plus 2. Phosphate is a polyatomic ion, PO4, and that has a -3 charge. So that's on your common ion sheet if you're wondering where I got that. So 2, we have a plus 2 and a -3. So you could do the math in your head, or you can do crisscross. Common multiple is 6. So then this should be Ca3, and then parentheses around the PO4, and then that 2 goes on the outside, like that. Okay, the next one, magnesium, and that has a plus 2 charge. Nitride. This is where you need to be careful on the endings, okay? Nitride, if it ends in "ide", then most likely that just came from the periodic table. So that one, they're talking about nitrogen with a -3 charge. So you can do your crisscross, or you can do the math in your head. So it's Mg3N2. And then the next one, iron 2 oxide. So that's telling you that it's iron with the plus 2 charge. And then oxygen or oxide has a -2 charge. So this one's pretty easy. Plus 2 minus 2, they already equal 0. So you only need one of each. All right, beryllium is Be, and that is in group 2. So it's plus 2. Chloride, Cl, and that has a -1 charge. So you can cross the 2 down there. The other one is just a 1, but we don't really need to write the 1, so it will just be BeCl2. All right, then the last one, potassium, which is plus 1. Chlorate, this is a polyatomic ion, ClO3 with a -1 charge. So that is found on your common ion sheet, plus 1, -1. So you only need one of each. Oops, erase that charge. No charges in the formula. Okay, so just be K and then ClO3 like that. Notice no parentheses around the ClO3 because we only needed one of them. Okay, we only needed one of them, so that's why the parentheses were not required. All right, I know that was a lot, and we will practice a lot in class. So make sure you come to class prepared with questions that you may have, and the only way to get better at this is to practice these over and over and over again. So you do have a homework page that has so many of these on them so that you can master this skill. All right? See you later. Bye.